ask compiler to find for me this implicit instance of implementation of my type class. If something will be unclear, let me know. Then we can go back and see how see what we can explain something better. So here is just an example for add. Yes, so I have defined a rational add, which is doing exactly that what was mentioned in the comment above. And here is just a simple test. Even here is compiler is saying me that here is implicit conversion to my add class. Yes, so this tuple here is converted, and let's say this is the simplest way. But type classes, let's say it does not. You do not have to use it only to define some arithmetic simple operation. You can also define other algebraic structures. Yes, like for example, something which is resemble to functor. Which one? No. Yeah. So the question, generally speaking, is why we are talking about functional programming and what does it mean? Yes. So what for it is. And let's say I was thinking about that long time. I'm writing a code in Scala, I don't know, last 4 years, something like that. But believe me, recently I just came into conclusion that functional programming means that we are handling with functions, and it means mainly that we are composing functions. So when we need something else, so actually we have to compose two functions. So usually we should maybe use known operators like combinators, rather I would call it, like compose and then, yes. But unfortunately, it's not working always, not for all, let's say, structures or all being, yes, it is working in this way. So people are thinking about that, and okay, so if I'm not able to compose just simple functions, I have to figure out some higher abstraction, which on this level, on the level of this abstraction, then I can compose these abstractions together, yes, like functions. So, and people always thinking about, okay, maybe let's think something like functor, yes, and the other algebraic structure you know from probably from some theory of category. So theory of category, generally speaking, is about the abstraction for functions. There's nothing more. The arrows means that this is something which, let's say, this is something like function, yes, or something I can compose. And all of these laws and rules you find there means that if I'm doing some composition on some level, I have to also, I don't know, match some isomorphism on the function level. Yeah, so I should not get the different solutions. So here is an example of functor. I'm not sure if this is really functor. The problem is, but it seems that, let's say, from the law I will show you beneath, looks like functor, but I'm not sure. Generally, what we need, yes, when we have a value, it would be fine to have something which lifts this value into function, yes, and it is done by the function unit, and actually does not have to be a part of this trait, because in Scala or in other languages, objected languages, when we have object or classes, this stuff is usually done by constructor. Yeah, and the second is just a defined combinator map, which is I could call it, this is a counterpart of compose on the function level. which takes two arguments. The first one is taking that what I need, yes, my function, and function which I would like to compose that function. So really nothing special, yeah. I do not call it fmap because I think that Haskell is for extraterrestrial guys, so I just stuck to map. Yeah, and what is interesting with this function is that actually I don't, in contrary to that what we had in add type class, here I can give and deliver the body of this function, yes? So when I can deliver the body for this function, means that actually I don't need any abstraction. So this is the reason why I define just an object func which extends func. So this is the reason why, yes. And again, I have defined an implicit class which just move my zero arity function at the head of the function. And this is my test. Yes, the first one, which is commented at the top. No, excuse me. I will talk about that a little bit. So this is not a test. I mean about this guy. So this is more or less how it looks like in Haskell manual. So this is the second law of functor, which more or less looks like in Haskell manual. And the dot means that I compose two functions A and B. Yes. How I tested, I just created, this is purely abstract functions, as you can see. I do not have any specific types. This is any type. I mean, for all types, I can let's say it. Yes, and I define my left-hand side. Oh, it's not visible here, oh man. This is a long line, so let me break it. Yeah, so I define my left-hand side and right-hand side, and let's say my all proof is that both have to be resolved to the same type, yes, to this type. If I compose this function in that way, I mean, if I compose two functors to each other, an array is not composing functors, it is just calling, given a combinator which is getting a function, but with some signature, yes, some types, and I'm doing it same, but in this manner, I should get the same type. So this is my test. And this is also the reason why we like functional programming, because part of some group of tests can be even skipped if we really, no, wrongly set, sorry. Rewind and erase it. This is more related to create a type system. Yeah? So when I create enough strong type system, then I'm able to prove many things for which, let's say in our Java world or another world, a dynamic languages world, needs tests. So here I don't need tests to prove that this is true. Yes, the compiler is doing it for me. Yeah. Okay, so here there is also, you will see that something has been commented. Yes, this is because we don't like this. We don't like this kind of writing. We prefer also to see it as we would also prefer the executing the map on the function which is not zero arity function but also unary function. Yeah, so instead of writing such a little bit strange notation, we can define in the line at the top, you can see, yes, that I can define another map2 function which gets a unary function, not zero arity function. So then I can combine the function in manner like it is done in last line, but you don't see it. No, align you in this line. Yeah, exactly. So here I have a F map and GG. So this is exactly what for. This is the second. So now let's go back to the type classes. What strange things we can do, yes? And we will do a really very gentle introduction into tagged types. So thinking about stack does not mean that we have to think about the structures, yes? I'm thinking about stack as a set of functions, some responsibilities. And there is a far analogy to that what we have in domain-driven design. But this is only the quirk of fate. So I think so. Maybe I'm wrong, but I have only such feeling that this is pretty similar to what we have in now. This is a really buzzword, yes, domain-driven design. And we know responsibilities, but we don't think about models. We think in terms of responsibilities. So the stack is not a structure for me. It is rather the, semantically connected functions. Yes. So I expect here two operations which are done on some container. Actually, I do not have to. Declare this compiler type as something which gets which is parameterized by type, yes. But from some reasons, it is good, yes. For example, we have a better type in there, and I see in these both functions that, let's say, my key player is T of C, so my T, yeah. Again, I create some implicit class to make this function. To make these functions infix. Sorry, not so fast. And there is a really very simple implementation. Simple because I'm using exactly existing structure, which is really adapted to that we can implement the stack. So I'm doing it on list. Yeah, so I have a really very straightforward implementation. But this is not what I would like to show you. I would like to show you that I can think about stack like about really something abstract. So my idea was what to do, yes, if my stack actually would be a string, yes, and I will have a numbers. I would like to store them into string, and not, let's say, that, something like sequence or something like that. So this is my first approach, yes. The problem is, yeah, that I have to first create some type which is parameterized by any type and say that this is string. Why? Because if I write here, I know that you don't see everything here, but maybe we'll see now, yeah. When I write here string, excuse me, yeah, I will get a compilation error that here this type should get some type parameter, should take some type parameter. So this is the reason why I created this, let's say, artificial type. And it seems that this is quite good solution. Yes, because I can create it and I can use it, but the name is relevant to this example. This is quite fine, but not perfect example. Why? Because when you look at the signature of push and pop, you will see this is not exactly that what we expect. Yes, I can write here, for example, any name in place of the type parameter, and moreover, actually, all of them are seen by compiler as a string. Yes? So this is the reason why it's not so perfect. But we have solution for that. And this solution can be seen in the last line of that what you see, but let me go somewhere else. And not here. Okay. Let me get a gulp of water. So, what are tags? Tags are tags. They are everywhere, yes. Even on the very bottle, which is standing there on that table. Yes? This is something which is, tag is a type. I mean, I have something, let's say, something really very basic, like primitive. And from that point, I would like to give it a name for it. And this creating of tags is quite simple, done in Scala. Yes, I need to actually define two lines. Yes, so the first line is container for type, and the second is creating a new type. Yes, where the T is usually some primitive type, and U is a label for this type, and this creates me a type. This is really very useful thing, and the closest thing, yes, to that what we see, yes, we will maybe realize that a little bit later, but in Scala we have also something which is called value objects. Yes, this is quite close to that. I will explain why. So we have these types defined, and you can see that, okay, I can define some this guy is alias for this guy, but actually this is a separate type seen by compiler. And in this example, there is some implicit conversion. This is maybe less important. We can go back, but what I would like to show you is this group of function. Yeah, generally speaking, what I would like to do is to write a function for computing the force. And I know from physics the force is actually mass, which is multiplied by acceleration. Acceleration is velocity divided by time, and the velocity is displacement or distance divided by time. Yes, all of them are integers in my example. They are numbers, nothing else. Yes, but I would like to have these numbers in correct positions. So I would like to be guarded against that situation that I will put here S, and here I will put T. Yes? And I will get a compilation error because I know that there is a small font. Unfortunately, I cannot make it bigger. But generally speaking, is what is here written. The most important two words are at the beginning of this statement. So the type mismatch. Yes, I was expecting that in this place, yes, required will be displacement, but I got time. Yes, and in place of time, I got displacement. Yeah, so this is what for I'm doing. I'm tagging my integer numbers. And what is really fine with it is that inside my function, so whenever I will get this argument when I pass this argument to function, inside the body of functions, I can use predefined operation which are characteristic for integer. I do not have to unwrap it. In case of value objects, when we have something like this is just for reminder, yes, then I have a case class or even a class which gets I'm not sure if I need this val of type int. Yes, and here is a magic word which extends is not a magic word. I mean, this is magic word. Yes. So in this case, I have something which I could call is equivalent of that what we have here. That is not really true because every time when I pass this argument A, the type of A, I have to unwrap this value and then make the operation. In this case, I do not have to do this. Moreover, when I define this class, here is define this class, which is using, I'm not sure this is visible, probably. Yeah. So when I have here some test class, and I have a type money. I have a method foo, which gets an argument double, which is start with money, yes. And when I will look at the bytecode, yeah, in bytecode I do not have any trace of this of the stack. So in bytecode I see just primitives. But of course, some will claim that what in case we would like to expose our API, such API, in jar file for other libraries. So sorry, guys, you cannot. I mean, yes.
I think that also another difference because with your approach, you allow money to be negative number, time to be negative number, and you do not restrict any value of other types.
You mean validation at the very beginning, yes? Okay, so this is in some point of application, anywhere. In some point of application, you have to do this validation, yes? You can say, okay, let's class do this, yes? But on other hand, I would solve it in different way. We have on one, just imagine, we are doing type classes. What type classes are about? Sets of primitives, yes? And the functions I apply on these primitives. So when I have some number, and I would like to have this number, let's say, applicable, I mean, for this set of my functions. So this, because this function, let's say, is doing something in the context of the set, this function could check it if my argument, even if this is tagged, is that what I am expecting. So even money, your example, yes, you can think about money as a negative number if this is a debt. Yes? So, I mean, that's what I want to say is that in some context, even some numbers, yes, has some meaning. It is, and in my opinion, it should be done by functions which are defined, which are playing on the set. Yes, I have split it. I do not have a one object, I mean one class, where I have inside that a validation things, I have some fields, and I have some functions inside that, or methods, which are applicable for let's say, the content of this object. I have it separately defined, and in some context the number can be money, in some other context maybe the same number, could be maybe, yes, can be treated as something else. Not sure what, but I can imagine, let's imagine that we can do this. So, okay, so this is about tagged types. So we know more or less what it is, that this is easy to implement, even in such unfriendly language like Scala. And going back to stack. So I'm using this trick, yes, to define a little bit better string in stack. Yes, the advantage of this solution is that whenever I change, and we show you, I change the signature here, for example, not like this, Control Z, not in this direction. I put here double, so this is oh yeah, that's 10%, man. No worries. Yeah, see, I have a compilation error, which will say me that I do not implement a method where the type is string stack of int. Yes, so method push is not implemented with this signature. I have some other. I have a double. So when I go back and I change and Z. I will change the other guy. So now let's remove it and leave here a string. So again, I have a compilation error. At this time, yes, again, I need a pop function with this signature, but unfortunately I define it for string. And there is also another advantage of this solution. There is another advantage of this solution. Yeah. So this is what I said, more or less, maybe between lines. Yeah, that I cannot. I have to say exactly that this string, yes, will play a role of stack, because when I just assign here just an empty string to stack, the conversion, yes, which is defined by that implicit at stack class, yes, won't be able. Will claim that is not able to. No, it will claim just not. It won't find that what it's expecting. So it's expecting string in stack of int, not just a string. Yes, and this simple conversion is done. Yeah, is done by this apply. Yes, here at because I just want to maybe let me. Yes, you don't like it because here is written as instance of. But generally speaking, this is what I said. There is a point in application that I have to be sure that I just here I have that what I really need. Yes, so I have a string, and then I turn it into my tact type. Yes, and then I can play with this tact type. That's what I said. And we are almost done. There is the last thing to show you. Oh, this guy. I'm sorry for presentation compiler errors, but believe me, I believe me that in case of IntelliJ it is even worse. So IntelliJ is for mainly there is an opinion expressed by my Sabin that IntelliJ is doing really very evil work because it's giving people only a subset of Scala, because people are not using libraries which are more sophisticated, using all language possibilities, capabilities, because people usually don't like red markers around their code. So in this case, in my opinion, Scala IDE for Eclipse is much better. So this is a commercial. Okay, about that. So we have a shapeless. I just want to say you and show you is that actually we do not have to define these tact types. They are also available in libraries like shapeless, but not only. There's also available in Scala Z, as I remember correctly. And what is worth to say that having a shapeless or such libraries like shapeless, I know this is not fine. We actually can construct all words without inheritance, without classes. Actually, all we need are really very simple structures like maybe tuples, yes, maybe some map. The record is just this is just a list. This is just let's say a kind of heterogeneous list taken from shapeless list of tuples. Yeah, so I have a tuple and a list, and with dynamics I can even call that name and the surname let's say in dot notation. You don't see it, but I will try to. Yeah, sorry. Like here, I know that this is the last line, but believe me, here is just conversion to the dynamic record, and I just call a name which is defined here. So I have that. What this example should show you more or less is that I have on one hand, I have really very simple structures. On the second hand, I have just a type classes. So this is there are sets of functions which can be applied in some context to these structures, and that's it. Yes, that's all what is really needed to model the world. And that's it. Any questions? Okay, you are stumped. I mean, a little bit confused. Something is unclear. We can go back or not, or you have to just consult the pillow.
For you personally, because we are comparing here the type classes and the operations, because we can combine the functions, and we can somehow compare it to the inheritance word when we are doing and we are.
Okay, so no inheritance. It is word where you have to. Okay, there is no inheritance here. You have only context, nothing more. There is a context. I know that. Yeah?
My question is, what is the biggest advantage for you to use the type class programming, functional programming, above the common class object word?
I don't like this kind of. I don't like. I mean, for me, advantage is that I have a clear separation between the structure and the responsibilities. Yes, but on the other hand, people will claim, this is not exactly what they expect from modeling, because usually we prefer tell, don't ask, not ask, don't tell. And we would like to have functions close to the structures, because when we refactor them, yes, we know what we should change. But on the other hand, you have something like such situation like that. You have some structures, and actually, you don't know exactly where the structure will be used. Yes, and when you, for example, okay, I have to use the structure in some, I don't know, database calls, so I have to know how to define a kind of session or some link between database, or maybe some serialization is a better situation, yes? So I have to serialize it to JSON and send it down. But on the other hand, I will ask you why you are bothering this structure with responsibility of serialization if this is used in some very specific, let's say, path or usage, yes? You have 10 more other places when you are using the structure, and only in one you need to have it serialized. So instead of that, I would prefer to deliver that functionality separately, yes, as a type class. So I define some set of functions, and I define some context. Okay, in this context, I would like to have it serialized. And whenever I import this or I define explicitly the instance of given type class, yes, then I can serialize my structure. So this is always some pros and cons. This is a little bit like in physics, yes, we have a corpuscular wave word. So this is pretty similar, yes. You have a function, but some things are better modeled by classes, by some encapsulations and others, this kind of things, some other by functions. Sorry for a long response, I hope. Anything else? You will start from tomorrow, yes?
There was this class, string stack of int. Can you show us how does bytecode look? How does it look after compilation?
You mean this guy?
Yes, like this, but with string stack of int.
I'm not good in typing
Maybe we
pace.